Assalamualaikum warahmatullahi wabarakatuh. Today I am going to present about our data mining project, which is job changes in data scientists. First of all, I am going to introduce about our group members. My name is Nur Anis Nabila binti Muhammad Saleh, and my group members are Ahmad Fahmi bin Abu Bakar, Muhammad Faris Farhan bin Fauzi, Muhammad Aiman bin Saifullah, and Hanis Ardini binti Muhammad Azman. Now let's start with introduction. In this project, we had used the dataset of human resource analytics of job changes of data scientists that was found in official website of kaggle.com. This dataset has 2,129 instances and 13 attributes mixed with nominal and numerical. This dataset is collected from people who had applied for job training in a company, so the information related to demographic, education experience is enhanced from candidate sign-up and enrollment. The company had collected dataset to find the applicable candidates as it will contribute to the reduction of training costs and time, as well as the quality of training or course preparation and candidate classification. We will implement this dataset to get the classification of which candidate suitable for this position. And moreover, this dataset explains that we can get better knowledge of a candidate that could be useful for decision making in choosing employee for this job position. Hence, the main objective of this project is to predict who will assign to this job training and get shortlisted candidates who are most applicable candidates. This slide lists the numeric and nominal attributes in the dataset. So the dataset has 4 numeric attributes, which are enrollee ID, city development index, training hours, and target, while the dataset has 9 nominal attributes, which are city, gender, relevant experience, enrolled university, education level, major discipline, experience, company size, and company type. My friend will explain about the data understanding in the next slide. Thank you.
So, Bismillahirrahmanirrahim. My name is Hanis Ardini. So, for my part, I will explain about data understanding, which is also called as data cleaning. So, in data cleaning, first we do the replace missing value. Because in our data set there's a lot of the missing value that we have identified. So in order to avoid excessive data loss in the dataset, we have to choose filter replace missing value, and this is the result after we do the replace missing value. And the second one is we remove the selected attribute. This is because some of the attribute in this dataset we not gonna be used in our our model evaluation. So out of 14 attribute, there are only 9 attribute in our dataset after we have select some the selected attribute. So the next one is the third one is we detecting outliers. Detecting outliers because we want to remove the instances as suggested. So we apply the interquartile range. And as you see in the slide, this is how we detecting the outlier, and this is the result. So it will appear outliers and extreme value for our dataset. So as you see, there is no outliers in our dataset, so that is why we do not do any things to remove any outliers. As you can see, the yes is 0 for outliers, and also for extreme value there is also 0. So that's all for my part. I pass to my friend. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fahmi. Now I want to explain about data preparation transformation. Among the transformation technique, we choose the discretization, which is the transforming numeric attribute into nominal, because in classification method, it cannot handle the numeric attribute. So we choose the training hour, which contain the numeric value. then discretize into three bin or into three category, which is short, moderate, and long. First step, choose the discretize filter, then edit the option, set the attributes indices into A, which is training our row, then set bin into 3, which is into 3 category. After that, click apply, so the attribute will be transformed from numeric into nominal. As you can see, the label values are in range, so to make it easy to read, so we need to change manually the label value in simple terms, which is short, moderate, and long.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Saifullah, and for my part, I would like to present about model development and evaluation for our project. Okay, as you can see, sir, for this project, the data set is analyzed using 3J48 for classifier, and we have two methods that we use. The first one is cross validation, and the second one is the percentage split. As you can see in the test option, that has four options, but we choose two: cross validation and percentage split. And the result list will display the test that we have been run. And for the classifier output, it will display an information such as the instance, the test mode, the size of trees, the number of leaves. Okay, so we go to the first method. It is cross validation. Okay, so the first one, we use K is 10. Okay, K is 10, and as you can see, there are two ways to determine how good our predictive analytic model. And the first one is at the classifier output, we see at the accuracy percentage, and the second one we see at the confusion matrix. Okay, so for the fault K is 10, okay, the correctly classified instance is 79.97 and 18%. And for the incorrectly classified instance is 20.028%. So for the confusion matrix, 1020 instance of class has relevant experience has been assigned to class no relevant experience, while 2817 instance of class no relevant experience have been assigned to class has relevant experience. Okay, so we go to the next. K is 20. So for the correctly classified instance is 79.9144%, and for the incorrectly classified instance is 20.08556%. Okay, for the confusion matrix, 1039 instance has relevant experience has been assigned to class non-relevant experience, while 2809 instance no relevant experience have been assigned to class has relevant experience. Okay, so we go to the next method. Next method, we use the percentage split. Okay, the first one is 70%. As we can see at the accuracy percentage, the correctly is 80.2158%, and the incorrectly classified instance is 19.7842%. So for the confusion matrix, 319 instance of class has relevant experience has been assigned to class no relevant experience, while 880 instance of class no relevant experience have been assigned to class has relevant experience. So we go to the next, is 80%. Okay, 80%. The correctly for the accuracy percentage, the correctly classified instance is 80.1148%, and the incorrectly classified instance is 19.8852%. 200 for the confusion matrix, 242 instance of class has relevant experience has been assigned to class no relevant experience, while 536 instance of class no relevant experience have been assigned to class has relevant experience. And when we want to see the tree visualization, we right click at the result list for one of the our test option, right click, and we choose the tree visualization, and it will display like a figure in the screen, and the number of leaf that we have is 122, and the size of trees is 110. 35. Okay, sir. And we also can review the predicted value by the model. Okay, and the first one, as you can see in the box, we go to the more option, and at the output prediction, we choose the play test, and you can see the classifier file output will display one has relevant experience and one has relevant experience. So the actual data has relevant experience and is predicted correctly. And that's all from me. And we will go to the next our friend, inshallah. Thank you.
Okay, so next I will explain about data reduction. So for the data reduction is used to improve the data accuracy and reduce the number of the leaf in the decision tree. The slide show how the rate qualities turn out for the reduced data. The relevant experience function in Weka is applied to the dataset. When relevant experience is applied to the dataset, the attributes are ranked based on the selected supervised attribute. But we can see low rank attribute have a low relation to the supervised attribute, whereas high rank attribute have a high relation to the supervised attribute. So for the result, the attribute that contribute the least amount of information to the class label will be removed. Okay, next for the cross validation, for fault k equal to 10, you can see the accuracy is 80.1023%, and for the incorrectly classified is 19.8977%. Next, for the fault k equal to 20, for the accuracy is 80.0397, and incorrectly classified is 19.9603%. Okay, so for the percentage split, for the split 70 to 30, we can see that the accuracy is 80.007, and for the incorrectly classified is 19.993%. Lastly, for the split is 80 to 20. For the accuracy is 79.88%, and for the incorrectly classified is 20.12%. For the tree view, the number of leaves is 164, and the size of the tree is 187. Comparison of full dataset and reduced dataset. For the full dataset, the lowest accuracy was k equal to 20, which is 79.9144%, while the highest dataset is 70 to 30, which is 80.2158%. For the reduced dataset, for the lowest is split 80 to 20, which is 79.88%, and the highest is k equal to 10, which is 80.1023%. The bar chart show the accuracy of the data set decreased significantly after the data reduction. Model evaluation revealed that the data reduction is important in determining data accuracy. Data reduction improve accuracy while reducing the number of tree and leaf in the decision tree. Okay, that's all from me.